Hi, welcome back to our channel. In this video, we will learn about quadratic functions and roots. Let's have a look at an example. How do we find the roots of a quadratic function? Right. So let's say you have an equation like this and they're asking you to solve this equation. Means they're asking you to find the roots of this equation, which means they ask you to find the potential values for x so that this equation can be satisfied. Probably you know that this is a quadratic equation, so there are two roots or two solutions. So how we have learned how can we use complete the square to find the roots. So let's see how can we, if you do the complete in the square, this would become x minus 3 square minus 2 equals 0. So how can we solve this one? So if we can move the minus to other side, it will become x minus 3 squared equal 2. So x minus 3 equal plus or minus square root of 2. X is going to be 3 plus or minus square root of 2. So there are two solutions. X is 3 plus square root of 2 and x is 3 minus square root of. So let's see how this will look like. If you plot this function, this would look like this. You learned from the previous lecture that we can use the complete the square to find the turning point, which is happening at 3 comma minus 2. They're asking you to solve it when this is equal to 0. So this is the 0 line and this is the function x squared minus 6x plus 7. So they're asking you to find the answers when this is equal to 0, means when it crosses these points. So what is the x values when this function crosses the x-axis? And we already found the answer. This one is going to be 3 plus square root of 2 and this one must be 3 minus square root of 2. So this equation has two roots. So as you should know that the maximum number of roots for a quadratic equation is 2. So sometimes you may have one root, sometimes you may not have any root. So let's have a look at an example where you have only one root. This is a similar example, but instead of 7 we have 9 here. If you use a completing the square, this is going to be x minus 3 squared equal to 0. And this is easy to solve because x minus 3 is going to be 0. So x is going to be 3. So this quadratic function has only one root. It has no. So how does it look like in a graph? If you plot this one in a graph, you will see the turning point is actually the root. So that is where this graph is meeting this y equals 0 line. So this has only one root. So let's have a look at an example where we may not have any root at all. If you look at this equation, if you use the completing the square, this would become x minus 3 squared plus 2 equals 0. So if you try to solve this one, we will have a situation like x minus 3 squared equal minus 2. Then we cannot able to solve this one, because if we want to continue, we need to find the square root of minus 2, right? Because x minus 3 equal plus or minus square. But there are no answers for square root of minus 2. If it is minus 2, then we will not have answer. So we cannot able to continue further. Therefore, this solution has no real roots. Okay, so you will learn there's a way to solve this one by using imaginary numbers, but for the moment you can say this equation has no real roots. So let's have a look at the graph, how the graph will look like. The graph will look like, as you know, this is plus 2. The turning point is here. The turning point happened at 3 and at 2, because that's what you got, number 2 and 3. So turning point is above 0. The reason why we don't have solution for this one, because this curve never meets this 0 line, y equal 0. This graph never meet or crosses this line. If it doesn't cross this line, then obviously we will not have an answer to this equation where this is equal to 0. Thank you for watching this video. In the next video we will learn how to use a determinant.